This is only a 2-day unit. We will do a class today. We will do notes on Monday. We will do a review and a quiz on Wednesday, and then the test will be Friday. It is very quick. It's going to be a short test. Okay? I will probably do more problems rather than less, which means your test might be slightly repetitive. Just because I know if I only make it like a 20-question test, then every question's worth 5 points, and if you screw up one, it messes with your grade a lot. I think you'd rather have a few repetitive questions and more chances to get things right. But what we're doing is dealing with square roots, or what we also call radicals. Okay? Radicals is another name for square roots. It's a name for a lot of different types of roots. We can do square roots, cube roots, fourth roots, fifth roots. For now, in Algebra 1, we're sticking with square roots. Okay? You'll get into Algebra 2 and spend a whole unit doing more of them. The main thing we care right now is to know what perfect squares are. Do we remember what a perfect square is?
Isn't it like one that's multiplied by the same?
Okay, we're talking about square roots here. Okay, so a perfect square is a number that can be square rooted evenly.
So 4 times 4.
Okay, there's a list of these that we are going to need to know. The perfect squares from 1 to 169. Okay, here's where we're going with this. Square root of 1 is 1. That's why it's a perfect square. What would be next? Which would be square root of what number? 4. So 4 is the next perfect square. What comes after 4? 9, because the square root of 9 is 3. Okay, the next one we're looking for is what square roots to give us 4? 16. After that, 25, 36, 49, 64, 81, 100. We're only going up to 169 because that's up through 13. 121, square roots to 11. 2 more, 144 and 169, which gives us 13. All right, these are ones that you need to know, okay? If you have trouble knowing these, start practicing these. These are the ones that you are going to have to know. You're not going to have a calculator for this at all. Okay, life gets infinitely more difficult in this chapter if you don't know some of the perfect squares. All right, so if we need to simplify a radical, okay, that is a non-perfect square. These are great. If you're given, what's the square root of 49, figure it out, 7, done. Okay, well, sometimes we have, instead of 49, we have the square root of 50. If you don't have a calculator, your answer is not type it in your calculator and give me a decimal. Okay, this point on in math, we want to simplify this without doing decimals. Okay, so here's our process. If you have any number in front of the square root, it's going to just come down and be multiplied into your final answer, so don't lose any number out front. If the number under the radical is a large number, we're dividing it by a perfect square in our VIP list here. Okay? We're not going to divide it like 2 and see if you get a perfect square. We're going to think of our multiples because we're smart enough to figure this out. Okay? If you don't get a perfect square, there's other ways to do this, to think about it, that I will show you. The steps really, honestly, don't make sense until I do an example with you, if we're just being completely honest. So I'm just going to go through number 1. All right? If we're doing a question like number 1, okay, first off, is 18 in our list of perfect squares? No. As soon as it is not, I need you to be thinking about what multiplies to give you 18. There are lots of options for this. We want to pick the one that has a perfect square in it. Okay, so I could do 3 and 6. Can I square root 3 or 6 evenly? No. Okay, 3 and 6 are both not in that list of numbers that we wrote down. What's another way I could divide 18? 9 and 2. Why might that be what I want to divide 18 by? Because I can square root 9, right? What is the square root of 9? 3. If you can square root something, what you get from that square root goes outside. So once I've square rooted 9, 3 goes outside. Can I square root 2 nicely? No. If you cannot square root something nicely and it doesn't break down further, it stays inside. That is considered the simplified version of the square root of 18.
So you don't do it where you put like 3 and 3 and
You can, but people do that wrong frequently. I choose not to do factor trees because people will go through that and not do it correctly and will circle things that aren't at the end of the tree and then start putting random stuff out, and it gets too complicated. So I just think of perfect squares that go into it. Okay. So we've progressed past our factor tree point. If that's what you have to do, we'll get there, but it's not always the best way. Let's try one like 2. Now, the difference between 1 and 2, there's one big difference here. What is it? There's already a number outside. Okay? Right now, we're just going to hang on to that -4 and bring it down. It's going to get multiplied by anything that I bring outside. Okay? But we're not going to deal with it on the inside. Now, let's look at 98. Okay, 98 is going to divide by some numbers, right? What I will probably give you for this chapter is the baby calculators. If you need help thinking of what does 98 divide by, that will allow you to do that. But if you try to square root, it's just going to give you a decimal, which isn't going to help you on that part. So that gives you enough to help you divide. Anyone know something that 98 divides into? 2 and what? 49. Why might this be a good thing to divide by? Because I know that I can square root 49, right? What is the square root of 49? 7. Where does that number 7 go? On the outside. With the 4. What do we do with that and the 4? We multiply them. What stays inside? The 2, because I cannot square root the 2. So my final answer will be what I get when I multiply my numbers outside, which is -28 square root 2. You don't do anything after that. Your goal is to take anything from the inside and get it outside. I can't do anything with the 2 inside, so I'm done. All right, let's try that again with the third one. This is literally all we're doing. All we're doing. Okay, so we're just going to practice this again and again and again. All right, so let's try this with 3. What do I do with the -3/4 outside? Bring it down to multiply by what I bring out from the inside. Then I think about 48. I need to think about what goes into 48 that I can square root nicely. My first thing I think of for 48 is 6 and 8. That doesn't work great for me. Neither of them square root. 24 and 2. Do either of those square root? No. What else? 3 and 16. Why is that a good answer? 16 square roots. What is the square root of 16? 4. Where does that go? Outside. And I do what with the 3/4? Multiply. What stays inside? 3. If I multiply 3/4 times 4, remember if the denominator is the same as the number you're multiplying it by, they cancel. So what's my answer here? -3 square root 3. Do we have questions on 3? Yes. Yes, it's because literally 4 is like 4 over 1. So if it's the same number on top and bottom, it cancels.
So if it was like 5,
You'd actually have to multiply that by the top and leave it as a fraction. And that's fine. All right, try this with number 4 on your own paper. Okay, 4 is not super complicated. Give it a try and we'll check our answers together. With 4, we bring down the 1/2. We think about 12 as what times what? 4 times 3. Which of those can I square root nicely? 4. What is the square root of 4? 2, which we multiply by the 1/2. 3 stays in. What's 1/2 times 2? 1. Do I have to write a 1? No.
Wait, do you always have to square root it?
You always have to square root it. That's why we're choosing those, because we can square root it. If you can square root it, it goes outside. If you can't square root it, it stays inside. So you can't take it out until you square root it. Always. Because that's how we got back up here. We took the square root of 16 and got 4. We took the square root of 49 and got... On this then, my final answer, I would write it as the square root of 3. If for right now you're not comfortable without writing that 1 out front, you can, but you're not required to. If there's no number out front of a square root, it's always an understood 1 anyway. So either way would be fine. All right, let's try that with 5. Okay, we're almost done with this stuff. On 5, we bring down our 2. And we think about 50 as what times what? 25 times 2. Before we can take out the 25, we have to square root 25, which gives me what? 5. We multiply that by the 2 that's already out there. What stays inside? The 2 that was left over. Okay, what's our final answer? 10 root 2.
Is that the simplified?
Nope.
Can you make it 5 root 1?
Nope. You can't simplify things that are inside and outside separately. You got to leave it there. It's a good question, though. All right, last one on this page that we're going to do is 6. Okay, 6 is more of what we're going to be doing on Monday. Okay, the difference between 6 and the ones we've done is what?
There's variables.
There's variables in it. Okay, so if I was to do this, I handle the numbers and the variables separately. Okay, so there's nothing outside to bring down. So first thing I do is I think about 27. What goes into 27 that I can square root nicely? 9 and 3. Okay, 9 square roots. What is the square root of 9? 3. That goes outside. What stays inside? That 3 that we couldn't square root. Now I deal with the x squared. Okay, anyone know how to? Okay, we can think about x squared as x times x, right? Well, what makes a perfect square a perfect square? Like our whole list that we had there. Why is 16 a perfect square? Because it's 4 times 4, right? So if 16 is 4 times 4, the square root of 16 is just one of those. 1 4, right? So if x squared is x times x, what's the square root of x squared? X by itself, and where does that go? Outside. Are there any x's to stay inside? No. We'll practice with the x's a whole lot more. I want to get comfortable with the numbers first.
Wait.
Typically, you put the number, then the variable, then the square root. Yes?
I'm still confused on why you put it outside.
Anything that you can square root goes out. Anything that you cannot square root stays in.
But 2 isn't on the list, though, so...
That's not 2, though. It's x squared. It's not the number 2. It's the x squared. Yes. All right. Flip to the back for me. All right. What I would like for you to do is with your tables, okay, take a look at 7, 8, and 9. 7, 8, and 9. We're going to come back together to talk about 10. First off, there's your answer for number 7. 99 splits into 9 and 11. If you square root 9, you get 3. That goes outside with the 9 that was already there and multiplies. Any issues with 7? Okay, 8's the first place we've run into a small issue that I've heard most of you discussing. Okay, how many of you tried with 32, 4, and 8? That is not incorrect. It is just not fully complete, because what's true about 8? It breaks down also into what? 2 and 4.
Wait, 8 is not square root.
8 doesn't square root, but a number within 8 does.
Oh my.
All right? What happened here? What happened here? It's not wrong. It's just that there is a larger perfect square that goes into 32. Okay? What is the larger perfect square that goes into 32? 2 and 16. Always use the largest one.
So try to divide 2 first.
It's typical. Try to divide by 2 if you can, yeah? So if I square root that 16, what is the square root of 16? 4. That goes outside with the 3 that's already there. What stays inside? 2. right? So there's a 12 outside, a 2 inside. Last one on this line, and then we'll finish up the last one and be done with this. The 2/5 stays outside. What does 75 divide into that I can square root nicely? 25 and 3. Square root of 25 is what? 5. That goes outside with the 2/5. The 3 stays inside. If I multiply my 2/5 and my 5, what am I going to get? 2 root 3. All right, last couple. If you ever have a fraction, it's not that you have to think what perfect square goes into 4/25. You may square root the top and the bottom of the fraction separately. Can I square root 4? What is the square root of 4? 2. Can I square root 25? What is that? 5. I left the negative that was already out there. That's all you're doing on that one.
You don't even put a red for it?
Nope, because you square rooted both, so is there anything left to be inside? No. If you have a decimal like this, okay, this is not in fraction form, you want to put it in fraction form. If it is 0.16, I can make that the fraction 16 over what? 100. That's the easiest way to do it. Because the 6 is in the hundredths place, you can put it over 100. I can handle this the exact same way as I handled the last one. Can I square root 16 evenly? What is that? 4. That goes outside. Can I square root 100? Yes. What is that? Huh?
25.
No.
20.
What times what gives me 100? 10 times 10. All right. Is there anything left to go inside if I can square root both? No. Last question, is this fraction fully reduced? No. So what does it go to? 2/5.
Could you also just put a 16 in there? I just had
What do you mean? You have to because it's a decimal. It's not 16. It's 0.16. Last one. Keep your 4. How do we think of 500?
25 and
Bigger than that.
25 and 25.
5 and 100.
yeah, this will work.
Sure it does. What's the square root of 100?
No.
Oh. 10. That goes outside with the 4. What stays inside? 5. That gives me what number outside? 40. What number inside? Before you ever tell me something is your final answer, check the number inside. If that number can break into something that you can square root, you need to keep going. So for those of you that on number 8 went with 4 and 8, let's just go back up there quick. If I had gone with 4 and 8 for 32 and I square rooted 4 and got 2 and that went out with a 3, I'd have a 6 outside and an 8 inside. I cannot say that that's perfectly simplified because I could be given that problem originally and say, well, 8 splits into what? 4 and 2. So I can keep going.
Oh,
So you could keep going and just do 2 steps on that, as long as you keep going. So if you went there first, then I would say, okay, 4 times 2. Square root of 4 is 2. It goes outside with the 6 and multiplies and gives me what? 12. And the 2 stays inside. Did I get the same answer? Sure I did. It's just 2 steps instead of 1. Okay? Questions on that? All right. We have a couple practice things that we're going to do together to practice this, and then I'll give you some homework time.